In this video, we are going to review the Stenger test and how to perform that test within the Studio software by Medrex. The Stenger test is typically used to evaluate if an asymmetric hearing loss is true or non-organic. The Stenger principle is stating that when two tones are presented to both ears at the same time at different intensities, the patient should only hear the louder tone. This is because of the binaural interaction of the tones. And even though the lower intensity sound is physically presented to the ear, the patient would only hear the louder tone. The Stenger is performed when there is a 20 decibel difference between ears at one or more frequencies. In this example here, you can see on the audiogram that the right ear is the better ear and it has 10 decibel thresholds. The left ear is the poorer ear and that has 60 decibel thresholds. The Stenger procedure is when at a particular frequency we present a tone 10 decibels above the threshold in the better ear, which is 20 decibels on the right, and 10 decibels below the threshold in the poorer ear, which is 50 decibels on the left at the same time. You can either ask the patient to tell you which ear they hear the sound in, or simply use the same instructions you would when finding threshold and just tell them to respond when they hear the tones. The negative Stenger is when a patient responds to the sound in the better ear on the right because the tone is presented to the poorer ear truly below the threshold. So if these were true thresholds and the patient really could not hear the sound at 60 decibels on the left, then presenting the tone at 50 decibels on the left would not elicit a response that they heard the sound on the left side. They would only hear it on the right side, even though the presentation is louder on the left. A positive Stenger is the opposite. So it's when a patient does not respond at all to the sound, or they say that they heard it on the left. The patient should have at least heard the tone because it is presented to the better ear on the right louder than the threshold. Also, per the Stenger principle, when tones are presented to both ears simultaneously, the louder tone should be heard. If the thresholds are non-organic, the tone will be heard in the poorer ear on the left, in this case, because the presentation level is louder than it is on the right. So now let's take a look at the Studio software and how to perform the Stenger test within it. This is the main screen of the Studio software. When you open it, you will see modules that are dependent on which products you have from the Medrex platform. So you want to click on the audiometry module, and you can see on the top we have different tabs for different types of tests that we can perform within this module. So the first one is the tone tab, and you can see you have frequencies that we already plotted on here to use as an example, and they match what we were previously talking about, with the right side being the better ear at 10 decibel thresholds and the left side being the poorer ear with 60 decibel thresholds. On the top you can see that there's a Stenger tab, and we can click on that. This is where we can perform the test and mark whether or not there was a response to the tones being presented. So just for an example, at 1000 Hertz, we are going to change the tone volume here on the side. You can either slide the sliders, you can use the arrows up and down for the right and the left side, or you can use your arrow keys on your keyboard, and you can use the up and down and it will change the left side. If you hit Control and up and down on the arrow keys, you will control the right side. So in this case, we want the right ear to be given a tone of 20 decibels. So let's change that. And on the left side, we want the tone to be at 50 decibels, and so that's already set there. And you'll see on the right hand side that we are using the same transducer that we had originally on the tone tab. and the sound is being presented to both ears at the same time. So what we want to do is present the tone, and at this point we would ask the patient to either just let us know when they hear the tone, and the other thing to get even more specific would be to have them let you know which ear they're hearing the tone in. So if we presented the tone now, in our software you'll see the test button will have an illuminated speaker, and those speakers also show on the audiogram as well while you're testing. So that way you know that the tone is being presented to both sides. If the patient responds that they heard the tone in the right ear, then you know that everything is fine and that the Stenger is negative. If the patient either does not respond or they say that they heard the tone in the left ear, you would want to mark this as no response, like that, by clicking on the no response button there, because that would mean that we had a positive Stenger at that particular frequency. So once we do that, then you can see that the software put a bold line here, and it also marks what frequency and the intensity that we presented each ear. So then on this one we will see that we had the positive Stenger at 1000 Hertz. On a printout we can take a look in the legend also, and it will show us that same information. So in the software here, if you click on print at the top, you would want to select your template that you have. You can either hit print preview or you can just print it. But on the print preview section, it shows you those same marks on the audiogram graph, and then also in the legend here you can see that the Stenger is listed as positive and that it was presented at 1000 Hertz.